Hello friends, welcome to my channel. Let's have a look at problem 57 now, insert interval. In this video, we're going to explain a method based on sort and linear scan. So in other words, we're going to first transform this problem into interval merge type and then solve the problem using the same method as in problem 56. First, I'll read through the problem statement to digest the requirements, and then we explain the general principle and work out an example, and then we write the code. First, let's look at the problem statement. So here we are given an array of non-overlapping intervals called intervals, where intervals I equals start and end represent the start and the end of the ith interval, and intervals is sorted in ascending order by start I. So we are also given an interval called a new interval, which has a start and end that represents the start and the end of another interval. So we are required to insert the new interval into the intervals list such that intervals is still sorted in ascending order by start I, and intervals still does not have any overlapping intervals. So here we are required to merge overlapping intervals if necessary. So we are required to return the intervals after the insertion. So this is the main problem statement. So here are two examples. Let's first look at example 1. So in example 1, so the intervals consists of two intervals, 1, 3 and 6, 9. And the new interval is 2, 5. So if we look at the relation of this interval with 1, 3, so we notice that they have overlap, and the union of the two intervals is 1, 5. So we could get 1, 5. And then we check 6, 9. So 6, 9 and 1, 5 have no overlap. So we append 6, 9 to the output. So overall, the output for example 1 is 1, 5 and 6, 9. So this is example 1. So in example 2, so the interval is 4, 8. So if we look at 1, 2, so there's no overlap. So we append 1, 2 or add the 1, 2 in the output. And then we look at 3, 5. 3, 5 and 4, 8, and they have overlap. And the union of the two interval is 3, 8, right? So we now have 3, 8, and then if we look at 6 and 7, so 3, 8 covers this one, so we still have 3, 8, and then we look at 8, 10, right? 3, 8 and 8, 10 have overlap, and the union is 3, 10, so we have 3, 10 now, and then 12 and 16 have no overlap with 3, 10, so we are going to add 3, 10 into the output. And then we check 12 and 16 because it has no overlap with the previous one, 3, 10. So we add this one also in the output. So the overall output consists of 3 intervals, 1, 2, 3, 10, and 12, 16. So this is example 2. So before we do the analysis, let's look at the constraints. First, so the intervals can be empty. So this is a difference from problem 56. Secondly, so the interval length is bounded above by 10 to the power 4, right? So this gives or confines the problem size. And secondly, so each interval I has length 2. So in other words, the interval is represented by a length 2 list. So this is on the range of start and end, so which is in between 0 and 10 to the power 5. And the intervals is sorted by start at the very beginning in ascending order. And the new interval is also a length 2 array. So the start and end is the same as above. So with that said, so we are ready to do the analysis. So before we do the analysis, let me explain the general principle again. So here we are going to consider a current interval represented by S and E, and a previous one moving S and moving E. So we're going to consider two cases in the process. So the first one is the moving end is less than the start of the current interval. So in this case, there's no interval merge, right? So we just need to update. The moving S will be the S, and the moving E will be the E. So that's one case. Another case is that so the moving E is greater than or equal to S. So in other words, the current interval S and E has overlap with the previous interval moving S and moving E. So in this case, we need to do interval merge. So after the merge, so we're going to update the moving S to be the moving S, because moving S is less than or equal to this S if we do sorting. And then the moving E will be the max of the moving E and the current interval E, right? So that's the overall principle or overall relation. So here the sort is meant to give us a reference for comparison or check overlap, as in problem 56. So with that said, or with that explained, we are ready to do the coding. So the coding actually is very straightforward. So actually, essentially the same code as in problem 56 can work here. So here, what we are going to do is that we first add the new interval or append the new interval to the intervals list. And then we do the sort according to the start of the interval. And then we do interval merge exactly as in problem 56. In other words, the same code there actually solves this problem here. So with that said, let me first do this. First, I'm going to transform the current problem to interval merge type. So how can we do this? First, we can do intervals. So we are going to append this new interval. And then we do a sort intervals. So we can sort in place. So if we don't specify the k, so we are going to first sort according to the start, right? So that's what we need. And then for convenience, I'm going to retrieve this n. So it's the length of the intervals after we add this new interval, right? So essentially the original length plus 1, right? So in this n will be greater than or equal to 1, right? So because of this constraint. So with that done, so we're ready to do the interval merge. So interval merge. So here, essentially, we can use the same code as in problem 56. You're welcome to check out that video. So here, let me write with a slightly different, just to make the logic more clear. So first, I'm going to treat a set case. So that is if n equals 1. So this is very special. It means that the intervals originally is empty. So we just have one interval. So we just need to return it. Return intervals. So that's the one case. So now let's look at the general case. So for the general case, so we are going to do this. So let's initialize a result variable. We are going to return its final state after we do linear scan of the intervals. So then we're going to specify moving S, moving E to be intervals 0. And then we do the linear scan. So for I in range 1 to n, right? And then the current start and end is nothing but intervals I, right? And then we want to compare the relation of this interval, in other words, the moving S and the moving E, with respect to S and E, the current interval, right? First, if moving E is less than the current start, in other words, the previous moving interval, moving S and moving E, has no overlap with the current interval, then we're going to do append. We append moving S and moving E to the result. And then we're going to do the update. So moving S and moving E will be S and E, right? So this is one case. Another case is that, so the moving E is greater than or equal to s. In other words, s is smaller, no larger. So in this case, so we know the current interval s and e have overlapped with moving s and moving e. So we're going to do this. So essentially, moving s is still moving s, right? So because we have done the sort. So basically, moving s. So let me write it here just for clarity. Moving e will be the max of moving e and the e, right? So this is the case. So let's delete this line because it's redundant. And then, so we need to pay attention to the case if I equals n minus 1, the last interval. So we need to add this moving s and moving e because we have no other iterations followed. So we're going to have moving s, moving e, right? So once we've done the for loop, so we're ready to return the result. So this actually forms a solution format for this problem 57. So now let's first do a check, I guess. So for this one, this passes the first one. Now let's look at the example 2. Let's copy it again. So yeah, it passes the second example 2. So now we are ready to test the generic case. Yeah, it passes all the generic cases. So I guess that's about it for this specific problem. So actually here we're using essentially the same idea and same code to solve this problem. In other words, we transformed this problem into problem 56 or to a type called interval merge. So this is the end for this current problem and this video. In the next video, we're going to explain Leetcode Problem 495. So this problem 495 can also be transformed to interval merge type. So actually there are more examples in Leetcode we're going to cover in follow-up videos. So you are welcome to follow up and check out those videos. With that said, I guess that's it. Thank you.